I have a question for you,
Hey, Bill.
if you don't mind. I know that, of course, you are also well known for the incredible explorations that you've developed for many years. I remember watching this incredible episode of you and Phil Short, I don't know how many weeks inside a cave somewhere, which I thought it was really cool. But what do you feel when you find something that is new for the first time? What do you is it different to do that using a robot and looking at the image on a laptop screen? Or is it, what do you feel when you are not there in the water exploring the cave?
Yeah, I'll tell you a short story. I was at a space conference back in the late 1980s, and there was a session on planetary exploration, and the chair of the session was Red Whitaker from Carnegie Mellon University. And anybody who knows anything about field robotics would know that name. And there were members of the press in the audience, and one of the guys asked Red, well, what is the most exciting thing you can imagine, in terms of exploration? And he got thoughtful and he said, well, I think seeing an image of an unknown planetary surface come in one raster line at a time is about the most exciting thing I can imagine. And I put my hand up in the audience, and Red looked over at me and he says, okay, Stone, go ahead and say what you're going to say. And I said, I can imagine something better, being there and looking at that sample with my own two eyes and holding it in my hand. And I still feel that way. So I am reluctant to give away the privilege of exploration to a robot unless I am forced to do so. And unfortunately, as we have seen, with the technical diving revolution, there was a door that was opened, in the late 1980s when we started using helium, and then rebreathers came on, and we found that, okay, we can go radically beyond 40 meters depth, which was, that was the public safety limit in those days. And then suddenly we found that we could go as far as 200 meters and work safely using helium and rebreathers. And that is still true today. It's when you start going beyond 250 meters that things become gray and you run into problems with human physiology. And so a new barrier had been revealed to what we have to think about. And so, is it the end? Not necessarily. As I mentioned, Harry Harris and crew are working on a hydrogen-based diving system for the piers, and we're working with them on that. There is a limit, though. It will probably be in the range of 300 to 350 meters. It's not unreasonable. It has been done with commercial diving. They have much better infrastructure than cave divers will. But that is kind of a limit unless you move over to 1 atmosphere suits of the kind that Phil Newton has been attempting to produce. So that's kind of the trade space. I think it's humans pushing and possibly morphing humans inside a robot, and then finally moving to full robotics, with somewhere in the middle there where the robot is an assistant to the diver. Might be your safety diver just following you along, and if it says, I don't like the readings you have on your rebreather, I'm going to take you back out, and that could be a beneficial thing.
Yeah, great, thank you. So before I hand out the audience for the rest of the Q&A, I just like to say 2 things. The first is that you will miss the selfie that we'll take with those guys. I know that you are not into social media, but we've been talking also about that. And they will have a selfie. You don't have a selfie because you are not here in person with us. But for the next year edition, and I launch the invitation right now to you, if you want to change a scenery from that inhospitable Antarctic or Arctic location that you were, I can assure you that here there's sunshine, good weather, and an incredible mood during the weekend. So I expect you to come and join us in person for the next year. So if more questions to this panel, please. Okay.
Thank you for the talk.
Bill, you mentioned hydrogen, and maybe think of a couple of years ago when I spoke to a tech instructor about increasing helium prices. And I said, well, COMEX has been doing experiments with hydrogen, and he kind of scoffed at that, and he said, yeah, well, it's very flammable, and he mentioned infrastructure and that it's very hard to do, and he kind of brushed it off. I was quite surprised when you said that you were working on integrating that into rebreather technique. Do you feel that this might eventually replace helium or be used on a large scale in maybe at least tech diving?
To answer the last question, no, I don't see it as replacing sat diving. I don't even see it replacing helium for cave divers. It's a very, very special niche thing where you want to try to do surface-based diving to the vicinity of 300 meters. And Harry and those guys are incredibly meticulous. And to answer the question about flammability, it turns out that is actually more of an open question than people thought. We had the privilege of working with JPM Bear, who was involved with those COMEX dives. And it turns out that their data set for the flammability of hydrogen was based on some premises that aren't necessarily correct for rebreather diving. For one, they were working in a non-100% humidity situation, which likely will raise the flammability ignition point. And then the second point, which is it's almost a simplistic one, is that what is the difference between rebreather diving and what they were doing in a chamber? Well, one thing is there really aren't many ignition points possible in a rebreather. And so true to form, Harry just went out and made up some hydroliox, put it in his rebreather and breathed it in a pool. And found out that, from that very limited amount of empirical evidence that, working at 4 to 5% oxygen didn't simply detonate by itself. So, it reminds me in a way of the myth that surrounded the use of helium in cave diving back in the early 1980s. And we were convinced had been told, that it was dangerous and you were going to die, not because of the helium, but because of the decompression procedures that required oxygen at 20 meters. Well, nobody really knew that you didn't have to follow that procedure to decompress. And that was the key to opening the door. And it was only because of a serendipitous story that the Navy Experimental Diving Unit at that time was looking at helium diving, and one of the guys who was the chief medical officer observed that the profiles were very similar to the extended air decompression profiles. And what that meant is if you dived heliox 7921, basically the oxygen content of air, you could safely use the air decompression tables, which we did, both at Wookiee Hole and on the Andros project, and then later on the Wakulla project. Although by that time, Bill Hamilton was designing custom decompression tables. So I see it as kind of like where we are right now. There's limited amount of evidence of use. The procedures need to be re-examined again for the special case of a surface-based dive to depth. But I do believe, based on physiology and neurology, talking to Simon Mitchell and others, that probably 300 to 350 is going to be about the limit of where you can go with that.
Is a limiting factor? Sorry, I think my microphone went off. There is a limiting factor that makes you say that it's not going to, take over the diving world in the sense that helium has?
No, it's not going to take over the dive world. Helium is a nice, safe procedure down to about 200 meters, and you can do amazing things to 200 meters with rebreathers. So I don't think, we're going to change the world there. It's as I say, it's really only a specialization for the case where you're doing surface-based diving without decompression infrastructure of the kind that commercial divers would have, a saturation chamber, transfer capsule, and things of that nature. And it's very hard to set that kind of infrastructure up for cave diving. We did at Wakulla Springs, but that was a very special case where there was open access to relatively deep water, and we could get the divers back out. So you're still facing this problem of the descent rate, from the surface to 300 meters. That is the big problem. And even hydrogen has certain narcotic characteristics. So it's, I think it will advance. I think this will happen. I think, that Pierce Dive will go ahead and they will come back alive. But I don't think it's going to be, the thing that everybody goes out and starts using.
Bill, this is Mark Kenny from Paddy, and a question for you, and possibly Carlos will have an opinion too. Could you comment on the difference between having a fully autonomous robot that's been programmed for all the eventualities you can think of, and essentially machine learning, where it's actually teaching itself as well? Where are we with that?
Well, Carlos has not been saying much here, and I would very much like to hear his response first, and then I could perhaps add.
Well, in nowadays, and Bill can tell that better probably, AI is a process that you have to teach. And for teach, you need a lot of data. And underwater data for all the environments, it's something that we don't have in big quantities. So we need to collect a lot of data to then train the nets. And after that, I believe we can succeed with AI in autonomous robots. Yeah. What do you think, Bill?
Yeah, no, he is exactly correct. That is precisely the issue. You can't do machine learning if you don't have a large data set. And in fact, we just got back from Hawaii. We were out there with Bishop Museum, and we spent 2 weeks collecting coral 3D data from sunfish, with the idea of beginning to collect enough data whereby we could begin the machine learning training. But I think what we have found is that will be an extension. When you start doing a lot of some particular thing, let's say, for example, that we wanted to go out and explore every flooded cave on Earth that divers can't go to anymore. Well, the more of those we do, the more we can put that data into a simulation environment and have the robot correct itself for errors that we observe as humans. I mean, we can watch the robot in the simulated environment. And I mean, sometimes we get to watch it in the real environment where we're in the tunnel with the robot watching, and taking video. We usually do that in the early stages. But later on, once you have the data, the simulation environment is just as good as being in the real world. The robot doesn't know the difference. But what we have found is that behavior-based AI, this is where we have taken a step beyond what you would call choreography, scripted motion. For those of you who may observe the rovers on Mars right now, Curiosity and Perseverance, those are not autonomous robots. People may think they are, but they are not. I know the teams that run them very well. There's about 50 people on that crew, and they take the day's data, and then they will create a several hundred line script of what the robot is going to do the next day. And maybe in the end, it will move 10 or 20 meters. They don't want to lose a $6 billion robot because they made a mistake in autonomous code. So they're being very conservative. We don't have to do that. We can usually recover the vehicle from where we are. And so the idea is to push the envelope. And so what we have done, Carlos knows this, but most of you may not have heard this term, but the way that you create autonomy in a robot is through what is referred to as a hierarchical collection of state machines. And in robotics speak, this is have the humans think about what they would do in the environment and then try to reduce that to code. And it's harder than you think to do that, but it can be done. I had a great discussion with Rich Powell out at Bishop Museum, and he was arguing to me that a robot could never collect a fish the way that they do at 150 meters on rebreathers. I said, well, tell me what you do, to collect the fish. And he says, oh, well, you have to use psychology. And I said, well, explain how you use psychology. And he says, well, I observe the fish and I see that it has a safe place on the reef that it will always go to if it becomes frightened. And I said, okay, then what? He says, well, you encourage the fish to move away from the safe place, and then you put your net at the safe place, and then your buddy diver comes and scares the fish and it runs right into your net. And I said, Rich, what you have just described is a haptic behavior that I can code. And he had to sit there and think about it for a second. But anything that a human can do, eventually we can program. Now, whether we can actuate on it, for example, our fingers, right? You know, we're very dexterous with what we have here. We are making progress, you know, in the direction of hand-eye coordination with robots. And eventually it will get close, not exact, but it will get close. And so you can begin. I mean, you think about it, okay, well, how fast is a robot? Well, for me to match the speed of a diver with a net collecting a fish, that would take a lot of propulsive force. And so you run into these trade-offs. But the idea of behaviors controlling based on environmental data that is coming in, that's where things are moving. And eventually we just cut the data link, and the vehicle will go ahead and do that after we've been assured that even if it makes mistakes, it will still get safely home. And you know, knock on wood, we have not yet lost a robot, and I don't hope to do that yet or in the future.
Testing, yeah. Hi, Bill. It's Simon here. It doesn't sound like me. My voice has gone after trying to talk louder than your guitar playing on Sunday night last weekend. But this is just a comment really about the hydrogen question that someone else put over there. The idea is, I'm part of this PES group that Bill was talking about, and the idea is not to replace helium with hydrogen. The idea is to introduce hydrogen below a certain depth, which is probably about 200 meters, and then get rid of it on the way back up. And you kind of have to do that if you want to have the very high oxygen fractions that you need for decompression on a bounce dive. So it's very much a case of introducing hydrogen, using it for that period that Bill's talked about, you know, down to 50 meters and below, and then getting rid of it again during the decompression so that you can introduce your very high oxygen fractions later in the dive. Anyway, hi, Bill. Great presentation. Nice to see you again after a week.
You are a well-traveled individual, sir.
Hi, I had a question for the Aviad people. Do you, so I'm a scientific diver, and sometimes I need to be heavy on the bottom. Does your system, sorry, but the BCD then is ideal for me because it just allows me to be heavy. Does your system allow you to be heavy if you choose to?
Yeah, you can sit on the ground. It's the elimination of buoyancy is, as I said, it's more efficient than using weights. So you just add more water to the tank. Essentially, you're making your tank much, much smaller.
So you regulate how much water goes into your tank, correct?
Yeah, you can sit on the ground just like you do.
Okay.
Standard scuba.
Okay.
Yeah, because on the dives that I made, where I was trying to be neutrally buoyant just above the bottom, had I pushed the button on the pump, it would have pumped more water, which would have made me negative.
Okay, wonderful. Thank you.
Yes, I have a question about the Aviad. So what about when you dive for the dry suit? How does it work then when you depend for your buoyancy on the dry suit?
We actually have a slide just for that. It's after our presentation.
Oh, okay.
Yeah, we dove dry suits. There was a lady sitting behind you, Jennifer, who just dove dry suit on Maui. Yeah, what happens with dry suit, again, the system is far more efficient. And so you would lose a lot of weight. You won't need that much weight with a dry suit. You still need to manage the buoyancy of the dry suit itself. But what we found with dry suit divers is that when you have to manage 2 air pockets, it becomes far more cumbersome. And it's hard to describe what it is like to dive a system that everything is, you know, effortless, and then you just add the dry suit. So it's better, but you still need to manage the buoyancy of the dry suit.
And she can tell you that when she wore the dry suit with the Aviad system, she wore about half of the weights you normally would wear.
I do have the added question about what if it's not in a tropical environment? What if it's in the cold and you also depend on the air pockets to create warmth? So how does it react then?
The dry suit,
Just the same?
yeah, the dry suit will work in the same way. The system, again, the tank is just like today, it's the same regulator as today. So the air that comes from the, from the tank will feed the same dry suit. So it doesn't change the use of dry suits. It simply makes it better. It makes it more efficient.